Hey guys. All right, week 3, part 2. Okay, so in this video I'm going to look at the exploring factoring, mainly focused on the Khan Academy portion. I'm just going to work through a couple of those examples, and then the Google form that you complete is really the same kind of thing you're doing right here, so I'm not really going to go over that a whole lot. If you've got questions on that specifically, let me know. I think if you can do the Khan Academy, then the Google form follows from that pretty similarly. Okay, so you should have done the IXL first. Okay, my first video went through some of those. So on the exploring factoring, you probably want to start by watching Gina Wilson. Yeah, copyright Gina Wilson down at the bottom of our packets. You probably want to start by watching her video. She walks through a couple of practice problems, very similar to the ones you see here in Khan Academy. So when you click on the set 1 in Khan Academy, it's going to take you to a problem that looks like this. So like most of the Khan Academy, it asks you to do 4 of these. There are, over here on the side, if you scroll up, there's some videos that you can watch. So if you find yourself missing these a whole lot, you might just scroll back up and watch some of these videos. You can also click on where it says stuck, watch a video, or use a hint. Okay, so there's some options here that you can do. All right, so let's jump into it. Factor as the product of 2 binomials. So this is like going the other way from what we were doing on the IXL in the first activity. So we're trying to find the 2 binomials that are going to multiply to give us this trinomial, x squared minus 10x plus 21. Okay, so when I'm factoring these, there are 2 different ways probably that you saw this done last year. I think Miss Gibson would have showed you the box method. Okay, so just like when we were multiplying binomials in the first video, we'll start out with the box method here, and then for these types of problems, I'll show you guys what I normally do. Okay, I normally don't use the box for these kinds of problems, but the box method will get you the right answer. Okay, so I'm going to start by setting up the box. Okay, got my box here. All right, so I'm going to put the first term, can I get that closer? I'm going to put the first term in the first box and the last term in the last box. So the first term I had was x squared. See, that's going to go in the first box. And then I'm going to put the positive 21 in the last box. Okay, so the negative 10x needs to be split into these other two boxes, but I don't exactly know how it's supposed to be split yet. Okay, so I'm going to look at that 21, right? Since I am sure about that 21. And I'm going to think about numbers that multiply to give me 21. So in other words, factors of 21. Well, there's 1 times 21, right? There's 3 times 7. And that's it as far as factors of 21, right? So if you remember from last year, what we're trying to do is figure out a pair of numbers that are going to multiply to give us 21, but will add or subtract to give us a negative 10. Now last year, you would have made an X, right? I think it's called the X box method, right? The X in the box. And we would have put the negative 10 on top and the 21 in the bottom. And we need 2 numbers that will add to give us the top number and multiply to give us the bottom number. Well, the only pair that I have here that's going to combine to give me a negative 10 would be the 3 and the 7. And that's only if they're both negative. So I'm going to put negative 3 and negative 7 here in the X. So the X now tells me what needs to go in my box here. I had negative 3 and negative 7. So in my box, I'm going to put negative 3x and negative 7x. And it doesn't matter. I could have switched those 2 pieces and I would still get the same thing. Okay. So now what we're going to do is we're going to factor out the greatest common factor from each row and each column. So starting with the first row there, I have x squared minus 7x. The only thing that they have in common is that both boxes have an x. So out to the side, I'm going to bring out an x. Okay, on the bottom row, I've got a negative 3x and I have a 21. Only one of those boxes has an x, right? So since they both have an x, they both do not have an x, I can't bring an x out. But if I look at the numbers, negative 3 and 21 have a common factor, and that common factor is 3. Since this is a negative 3x, I'm going to make the 3 that goes next to it a negative 3. Okay, so now I have x and negative 3. I'm going to do the same thing with the columns. If I'm looking at the columns, then in that first column, I have x squared and negative 3x. The only thing they both have in common is an x. So I'm going to bring out an x and put it on top. Once again, in my second column here, I've got a negative 7x and a 21. Well, they both do not have an x, right? So I can't take an x out. When I look at the numbers, negative 7 and 21 have a common factor of 7. And just like I did with the 3 a second ago, I'm going to make this 7 a negative 7 because it's touching this negative 7. Okay, so now across the top, I have x minus 7. And across the side, I have x minus 3. So the factored form of this polynomial looks like x minus 7 and x minus 3. Okay, that is the first way that we can work this problem. Since this one does not have a leading coefficient, there is no number in front of the x squared, okay? We could actually do this process. It's the same process, but without physically drawing out the x and the box every time. So if I start with just x squared minus 10x plus 21, this, for me personally, is probably not one where I would use the box. It's kind of more, I think, time involved than we need to be here. So since I know that I'm going to break this down into a pair of binomials, I'm just going to go ahead and set up my parentheses underneath it. And we're going to do reverse FOIL for this one. So I know that the first thing times the first thing has to multiply to give me x squared. Well, the only way I can multiply two things and get x squared is if I had x times x, right? X times x is how I get x squared. Well, then again, I'm going to look at 21 and my factors of 21, 1 and 21, 3 and 7. And this is the same process as this x up here a second ago. We're just not actually physically writing it out. So the two numbers that are going to combine to give me a negative 10 are the 3 and the 7. But that's only if the 3 and the 7 are both negative. So in my problem, I'm going to put negative 3 and negative 7, right? X minus 3, x minus 7. Well, hey, look, that's the same thing that we got from the box method, wherever I'm trying to point, right here, right? We had the x minus 7 times x plus 3, or x minus 3. Here we have x minus 3 times x minus 7. It's the same thing. You should be able to type that in any order, and we'll get it, okay? So if there is no leading coefficient, if there's no number in front of the x squared, I would probably just use that second method, okay? But we get the same thing as if you use the box. All right, so I'm going to put in my answer here. X minus 3, close parentheses, new parentheses, x minus 7, close parentheses. All right, enter. Check. There it goes. All right, we got the happy chime, so we know we got it right. All right, I'm going to do one more. This one, oh, good. This one has a different kind of question, but it's asking you to do the same process. Okay, so for this question, they've given you a rectangle here, right? This ties into the box method. They told us that the whole rectangle has an area of x squared plus 8x plus 15. And then it says the width is x plus 3. And we need to know what the length is. Well, I know the width times the length gives me the whole area, right? So I'm really just trying to take this x squared plus 8x plus 15 and find the two binomials that it factors into. And they even told me that one of those binomials is going to be x plus 3. Okay? So I'm going to factor x squared plus 8x plus 15. I'm not going to use the box method on this one because there's no leading coefficient there. Okay, so here's how I have my problem set up. Now I'm going to take the first term, right, which was x squared, and I know that needs to be split into x times x, right? Well, then I'm looking at that 15. I'm trying to think of factors of 15. So I have 1 and 15, 3 and 5, and that's it, right? So there's my choices, 1 and 15 or 3 and 5. I need to pick the pair that's going to combine to give me positive 8x. Well, to make a positive 8, I need to use the 3 and 5. Okay? All right, and since we wanted a positive 8, the 3 and the 5 need to be positive. So I have x plus 3 and x plus 5. Well, hey, that x plus 3, that's what they told me should have been my width to start with, right? So I know I'm on the right track here because I'm getting the pieces they say I should be getting. Well, then I have the x plus 5. So the length is x plus 5 meters. Okay, let's check. Got it. Okay. All right, we're going to do one more factoring one. Okay, so this one has x squared plus 10x plus 24. All right, so again, there's no leading coefficient there. I would not use the box on this one. I'm going to set up my parentheses. That first term is x squared, so I know I need to have x times x. And then I'm looking at that 24. Well, for factors of 24, this one has a list, right? We've got 1 and 24, 2 and 12, 3 and 8, 4 and 6, right? There's all my factors of 24. All right, so I'm trying to pick the factor, the pair that's going to combine to make this positive 10. So positive 10. Well, there are two ways I think that I can get there. I've got this 2 and 12, and I also have this 4 and 6. Okay, so here's the thing, right? If I have two choices, I need to look very closely at the signs and think about what happens with those. If I use 2 and 12, one of those numbers has to be negative, right? Well, to make it a positive 10, the 2 would have to be negative, right? Positive 12 and negative 2 makes it a positive 10. But if I have a negative 2 times a positive 12, that makes it a negative 24. And we need it to be a positive 24, right? Not a negative. So the 2 and the 12 is not going to work, okay? You got to be very careful with your signs here. That means it has to be the 4 and the 6, right? And if we want a positive 10, then it's got to be a positive 4 and a positive 6. And if I multiply positive 4 and positive 6, I do get that positive 24 that we needed. Okay, so x plus 4 times x plus 6 would be my answer on this one. All right. Okay. All right. Okay, so I hope that this has helped with the first part on your Khan Academy. I think I'm going to do one more video that goes into the factoring that has a common factor, okay? And these we probably would either use the box method, or if we can identify that common factor, factor it out, all right? So if you need help with this next section, please look for the next video.